So today we are going to look into a very important aspect of blast furnace, that is Deadman Cleanliness Index. We will primarily try to see the reason of poor Deadman Cleanliness Index in blast furnace Hearth. So today we are diving into the critical issue of poor DCI in blast furnace Hearth operation. A low DCI can severely impact the drainage, carbon pickup, and overall furnace efficiency. Let's explore the root causes behind this phenomenon and understand how each contribute to operational challenges. Now coming to the poor slag metal drainage. This is one of the most important aspects, and it's gets affected very soon once DCI gets affected. One of the biggest culprit of poor DCI is ineffective slag metal drainage, and this is being repeatedly used by all blast furnace operators. When slag viscosity is high, often due to elevated basicity or excessive alumina, the fluidity of slag and metal is compromised. Add low hearth temperature to the mix and flow becomes sluggish. This prolonged metal residence time in the hearth means more carbon pickup and a higher risk of clogging. So, what is the key takeaway? It is about improving fluidity, and there is no compromise to it. This is the one of the biggest enabler. Now coming to the accumulation of fines in Deadman, we can say during these fines accumulation increases several fold. Unburned coke fines and heavy dust recirculation create physical obstructions in the Deadman. Using excess lump ore may seem benign, but it generates fines through degradation. Combine that with poor burden distribution and drainage become erratic. These localized blockages not only trap metal but increase carbon saturation also, which leads to creating a recipe for inefficiency. Coming to the high carbon pickup from the metal, as it has already explained, let us talk carbon pickup. When hot metal lingers too long in the dead man due to the permeability issue, it absorbs excessive carbon from the surrounding coke. Irregular tapping or low frequency only worsen the situation, allowing a stagnant metal to oversaturate. A quick diagnostic, then what is a quick diagnostic? So we have to compare actual carbon level with saturation threshold. A mismatch often points directly to clog dead man. It is a very easy yardstick. So now coming to the excessive Tuyere raceway coke consumption, and we can say that uh, onto raceway dynamics, such type of uh, Tuyere raceway coke consumption is become a very good diagnostic tool. Like high hydrogen or methane injection can accelerate coke degradation. Similarly, over rushing pulverized coal injection affect raceway stability also, leading to fines that block metal flow. If coke strength is compromised, it breaks down very easily, undermining deadman permeability. A weakened raceway creates zone that trap metal and reduce overall drainage efficiency. Finally, the hearth wear. As refractory erode, they distort the natural drainage pattern. The infamous elephant foot, a symptom of uneven erosion, further disrupt flow. Add severe thermal cycling and cracks. Allow metal to seep in, forming skulls that restrict movement immensely. These structural issues force metal to remain in deadman, compounding the DCI problems. To sum up, the boosting Deadman Cleanliness Index demand a multifaceted strategy. One of them is enhance slack fluidity by tuning basicity and alumina level. The other are like improve burden distribution for uniform permeability, minimize fines generation by regulating ore types and coke behavior. This also act going to take care of bad DCI very fast. Similarly, increasing tapping frequency to prevent metal stagnation is also a good way out. Optimizing PCI and hydrogen injection to maintain raceway stability is also a way out. So we need to see, we need to diagnose at what time we should use what sort of tool which remains compatible with the situation, and that can only gives us the best result.